All right, we're going to do Chapter 7, Section 3 and 4 today. And this deals with exponents. When you're multiplying two numbers with the same base, this 2 is your base. What this means, 2 cubed, means you have 3 2's. And 2 to the 4th means you have 4 2's. So if you were to think about multiplying those together, you have 7 2's. So this is actually 2 to the 7th, and you can just leave it like that. If you want to do 2 to the 7th, you could use your calculator. If you have a graphing calculator, you're going to use the caret button, which is right above the division sign, and you get 128. All right, 5 to the 1 times 5 to the 6 is 5 to the 7. This 5 to the 1 is also the same as 5. So if you have a 5 alone, you're supposed to know that's to the 1. And what that means is 5 times 5 times 5, 7 times. If you put it in your calculator, it should be a pretty large number. 78,125. But we're just looking for this exponent. We're going to go through exponent rules today. So basically, if you have the same base, you add the numbers in your exponent. So when multiplying, you add exponents. So 3 squared times 3 to the 7 would be 3 to the 9th. 4 to the 5th times 4 to the negative 3rd would be 4 to the 2. And do you understand what that negative 3rd means? When you have a negative exponent, you can move it to the opposite side of the fraction. And that's why we're getting a 4 to the 2, because we're actually dividing them out. We're dividing 4 5s. I just said 4 5s. We're dividing 5 4s divided by 3 4s. So 3 of them cancel, and we're left with 2 4s. All right, in C, we're going to put the base of 2 together. So that would be 2 to the 2. And then we're going to put the base of the 3's together. And that would be 3 to the 6th. And you can leave it like that. You can multiply them each out and put it all together. Typically, it's not really written this way, but we're just focusing on the exponents right now. So it's not a big deal. This you could just write as Q cubed R squared Q6. You don't necessarily need the dots in there. And then hopefully you're noticing that the Q's are together. So that's a Q to the 9 R squared. Typically when you're writing things in exponential form, you want to do alphabetical order. So M, N, O, P, Q, R. Q's come first, R's come second. Okay, this N alone is like a 1. So we have 3 plus 1 is 4. And then we have the negative 4. So that's actually n to the 0. And anything to the 0 power is 1. So either of these are a good answer. And then a 10 to the 5 times a 10 to the 8 is a 10 to the 8 plus 5, which is 13. And 4.2 times 2 is 8.4. Now, if this number in front of the scientific notation was more than 9.9, this needs to be between 0.1 and 9.9. If it was more, you have to get it so that there's one number and then a decimal. That's proper scientific notation. So you might have to tweak that and change your 10 exponent. All right, this is a little bit different because now we have a power to a power. So what this means is that we have 5 4 squareds. So this is actually 4 to the 10th. So when you're raising a power to a power, you actually multiply the exponents. I kind of like to think about it, writing it out, and think that you always add your exponents, that you don't get confused. But if this makes sense, we'll continue on. So 7 to the 4th cubed means you have 3 7 to the 4th. So So that'd be 7 to the 12th. 4 times 3 is 12. 4 plus 4 plus 4 is 12. Either way, you get 7 to the 12th. All right, anything to the 0 power is 1, so it doesn't matter what's in here, it's 1. It means none of them exist. I could put a 1 out front, and the whole problem doesn't change. If none of these exist, I still have my 1. And then x cubed to the negative 5th is actually x to the negative 15th. And if we're multiplying by x to the 4, you then add your exponents, and that'd be x to the negative 11. Since we're doing exponents, it's okay to have negative exponents. Typically in a problem, you would want to write that as 1 over x to the 11th. Now, this 4 is outside of the parentheses. So this 4 goes to both the 8 and the x. And we're going to actually go ahead and do 8 to the 4th. So 8 times 8 times 8 times 8 is 4,096. This is different than 8x to the 4th. 8x to the 4th is just 8x to the 4th. If the 8's inside of the parentheses with a 4 on the outside, you do need to raise it to the 4th. So when you're raising a product to a power, you need to put the power to everything in parentheses. And then you also multiply the powers. So this 2 goes to both. There's still the negative out front. 2 squared y squared. So it's negative 4y squared. This negative's on the inside. So that means the negative 2, there's 3 of those. So negative 2 cubed y cubed. So that'd be negative 8y cubed. Because 2 times 2 times 2 is 8. All right, this 2 is going to go to both. So we have an x to the 6 squared. That means there's 2x to the 6's. That's an x to the 12. 6 times 2. And then a y to the negative 3. That'd be a y to the negative 6. You can leave it like this. You could write it like that. Both of those are good answers. So we want to try to not have a negative exponent. We want the same bases to be together. We don't want to have a power of a power or a power of a product. And the coefficients we need to multiply out, if that makes any sense. So basically everything we were just doing in your final answer, if you had like 2 squared x to the 8, y to the negative 2, you would want to do that. And you would want to move that to the denominator to make it a positive exponent. All right, so this section is about negative exponents, and from here on out, you really don't want to have negative exponents at all. I kept saying in the other one it's not a huge deal, and then now it is, because this is where you learn that a negative exponent needs to become positive. So if there's 5 3's on top, and if there's 3 3's on the bottom, those cancel, and we're left with a 3 squared. It's the exact same thing as taking this up and subtracting it, since we have the same base. So when you divide powers, you subtract exponents. And that is limited by you must have the same base. And another kind of weird thing is if the top is smaller, like if in this problem if we had 3 to the 3 over 3 to the 5, If we subtract exponents, we actually get 3 to the negative 2, and you would need to write that as 1 over 3 squared, which is 1 over 9. Since we have a number, we should do it out. Okay, so 5 to the 6 over 5 to the 1 is 5 to the 5th, and 5 to the 5th is 3,125. X to the 4 over x to the 4 is x to the 0. Anything to the 0 power is 1. Hopefully you can just look at x to the 4 over x to the 4 and know that it's 1. So we're going to simplify before we start dividing. So this is really a to the 5, b to the 9 over a to the 4, b to the 4. So our a's, we have 5 a's on top, 4 a's on the bottom. That means there's 1 a left on top. You don't really even need the 1. Doesn't matter. And then b to the 9 over b to the 4. Remember, you can bring that up and subtract it, and that is b to the 5. So a, b to the 5 is a great answer. Okay, before we do the numbers out, we should put our same bases together. So this part simplifies to a 2 squared. This part either simplifies where you have a 3 to the negative 2 on top, or you can leave a 3 to the positive 2 on the bottom. You can actually take the 2 and bring it down and subtract it, and then you keep everything on the bottom. And then this is 5 to the 2. So 2 times 2 is 4, 5 times 5 is 25, 3 times 3 is 9, so it's actually 100 over 9. All right. 10 to the 8 over 10 to the 5 is 10 to the 3. And 2 over 8 is 1/4, which is 0.25. Now, if you had to put that in proper scientific notation, you need to rewrite the 0.25 as 2.5, and that would mean you have a 10 to the negative 1, because that's really 0.25. And then if you still have this 10 cubed, your final answer is 2.5 times 10 squared. So that's the best answer in proper scientific notation. All right, we're going to raise both the top and the bottom to the 4th. So 2 to the 4th over 3 to the 4th. So 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 times 3 is 9, times 3 is 27, times 3 is 81. And we can leave it like that. So when you're raising a to a power, both top and bottom, everything in the parentheses, both top and bottom, both numerator and denominator, all in parentheses. Get the exponent. Hopefully that makes sense. So, this 4 is going to every single thing. So this is really 3 to the 4, d squared to the 4, 4, e to the 4, f to the 4. So, 3 to the 4 is 81. D squared to the 4, remember you multiply this. This is 4d squared. So that's d to the 8, same thing as 4 times 2, over e to the 4, f to the 4. There's no like bases, so we're actually done. And everything's positive, so we're done. This is 2 squared, x cubed squared. Okay, now this simplifies to x to the 4, y to the 4. And then you need to put the 2 to both of those. So it's really x to the 4 squared, y to the 4 squared. So this is 4, x to the 6 over x to the 8, y to the 8. Now we're not done because these x's need to simplify. There's 6 on top and 8 on the bottom. We can bring the 6 down and subtract it. So that's 4 over x to the 2, y to the 8. All right, now a negative exponent, you can do one of two ways. Way A is you could put it through. So you could have 3 to the negative 2 over 4 to the negative 2. And then you would know that if it's a negative exponent, you move it to the opposite side of the fraction and make it positive. So the 4 to the negative 2 would move up and become a 4 to the positive 2. And the 3 to the negative 2 would move down and become a 3 to the positive 2. So we get 16 over 9. Now, the other way to think about this is you can do the reciprocal and make the exponent positive. Because if you flip this around, that sign will change. And we get the same thing. 4 squared over 3 squared. So whichever method makes more sense to you, go with it. We'll do it both ways if you want. How's that sound? All right. Bam to everything. So 2 to the negative 3, x to the 2 to the negative 3, and y to the 3 to the negative 3. So 2 to the negative 3, we would move to the denominator and make it 2 to the positive 3. Y 3 to the negative 3 is really y to the negative 9. So we would move that up and make that a y to the positive 9. And x squared to the negative 3 is really x to the negative 6. So we would move that down and make that a positive 6. So y to the 9 over 8 x to the 6, because 2 times 2 times 2 is 8. So if you think about that the other way, we could have just written y cubed over 2x squared and raised that to the positive 3. We would still get y to the 9, 8, and x to the 6. It all just depends what you think is easier. All right, so let's go ahead and flip this. So we have 3/2 squared, which is really 9/4. And then if we flip this, we have 2n over 6m to the positive 3. So 2 to the third is 8. N to the third is n to the third. 6 to the third is 6 times 6 is 36. Times 6 is 216. And m to the third. And then you can, 6 plus 1 plus 2 is 9. So 9 goes into 216. So these reduce. That's 24 to 1. And 4 and 8 reduce. That's 1 to 2. So we really get 2n cubed over 24m cubed. Now, I should have probably just left my 3 squared. Let's go back to this section. I probably should have left it 3 squared over 2 squared because it's a lot easier to cancel, because then you get 2 cubed n cubed over 6 cubed m cubed. So then you can see right away that the 2's, this is really going to be a 2 to the 1, and that cancels. So it at least takes the 4 out. Yeah. And then if you left it all negative, you would have 2 to the negative 2 over 3 to the negative 2 times 6 to the negative 3, m to the negative 3, over 2 to the negative 3, n to the negative 3. And then you would move every single thing. That moves down, and that moves up. So 3 squared over 2 squared. We're going to end up right where we are right here, times this whole thing moving up, 2 cubed n cubed, and this whole thing moving down, 6 cubed m cubed. So again, you're ending right there. We still actually aren't done because 2 over 24 can be reduced to 1 over 12. So n cubed over 12 m cubed. And we can't reduce 3 squared and the 6 cubed because it's not the same base. We could go through and try to change 6, but it's easier just to actually do it out and cancel it. All right, so that's it for 7-3 and 7-4. Hope that is making complete sense, and we'll do the in-class work tomorrow in class. Have a great night.